In this session, I'm going to explain analysis of variance. And as the title implies, this is much about variance. So what is variance? Variance is another typical measure of dispersion. In the t-test, you used a standard deviation as a measure of dispersion. But in essence, standard deviation and variance are the two same things, because standard deviation is simply square root of variance, and variance is simply standard deviation squared. So this is, as was the case for t-test, about dispersion. Now let's look at the data set. Now we're going to start looking at the second variable. Second variable is race, another categorical variable, but in this case we have more than two values. And we have continuous variable, same as in the previous session. So you have a categorical variable with more than two values and continuous variable. So your choice is Anova. And for the sake of easier illustration and understanding, I'm going to use only three values or categories of this categorical variable. So white, black, Latino are here. And again, you're going to have to numerically code these values. So I'm going to use 0, 1, and 2. And look at here. In the subsamples, it's all 0 here, or 1s here, or 2s here. So, and again, as you did for t-test, you're going to have to break down this sample data set into these categories, and eventually you want to see these subsamples. And once you do that, you are going to do univariate analysis of these continuous variable for each subsample. So you're going to find mean number of tickets for white subsample and standard deviation of white subsample, mean number of tickets for black subsample, standard deviation of black subsample, mean number of tickets for Latino subsample, and standard deviation of Latino subsample. And then, again, as you did for t-test, you're going to look at frequency distribution of number of traffic tickets for each subsample. Now let's talk about the first scenario. This is the distribution of white, black, and Latino. And remember the last session where I introduced these diagrams from different angle. So I'm going to try that here. So let's use different colors for each subsample. This is white subsample, black subsample, and Latino subsample. This is actually a conversion of this first scenario. So they are distinctively different, just like here, and there's no overlap between these two as well. There's no overlap between the subsamples, and this is the center of white subsample. So this is mean number of tickets for white subsample. This is mean for black and mean for Latinos. So now I'm going to introduce a couple of new concepts for Anova. First one is grand mean. Grand mean is simply mean of continuous variable in the sample. And you need to make a clear distinction between sample and subsample. This is your sample data set. And then you broke it down to these subsamples. So your sample is this. So mean number of continuous variable or mean value of continuous variable is just like mean of traffic tickets across all subsamples. So this is probably the location of grand mean. And then, of course, these are means of each subsample. So that's what we need for this new concept of between group variance. Between group variance. And between group variance is looking at the differences across groups, central tendencies. So you look at the distance between this subsample and grand mean, and the difference or distance between this grand mean and this subsample. And for the last one, the distance between this grand mean and this subsample. And you look at the totality of these distances. So that's going to determine your between group difference or between group variance. So sum of distances between subsample means and grand mean. And another and last concept that you need to understand is within group variance. Within group variance. I hope you understand this concept by just listening to the terms. But this is totality of variance in each subsample. So each subsample, there are cases all around the center and within each subsample. So variance is the distance between these cases and your subsample mean. So this is within group variance of white subsample. This is within group variance of black subsample. This is within group variance of Latino subsample. And again, you're looking at totality of it, sum of all these within group variances. So this is the concept, and with all these concepts newly introduced for Anova, you can actually calculate F value. F value is going to be as simple as between group variance divided by within group variance, and I'm going to talk about that in the next session.